Hey, it's Tony from Adafruit, and I'm trying out a new camera angle, so we'll see how this works in this video stream. But in this video, I wanted to look at the PCA9685 motor and stepper driver. So this is similar to the servo driver that I looked at in the last video, but this one is made for driving DC motors, or like a simple motor that can move forwards and backwards, or stepper motors, which are kind of fancy motors that can move in precise increments. So we'll look at how to use this. There's a feather wing that makes it really simple to and easy to use, and we're going to use it with MicroPython. So you'll learn how to use MicroPython code to move things around. And hopefully at the end we'll look at a really cool demo with the ESP8266 and a robot that you might be able to control over the Wi-Fi WebREPL. So let's just kind of dive in and get started and see how things go. So we'll switch to the main view right here. Let me turn on the desktop view. There we go. So, okay, and again, surprise, surprise, this guide, or this video, has a guide that accompanies it. So this is a new guide in the learning system, the PCA9685 DC motor and stepper driver guide. So this is similar to the servo driver guide that I did last week, but again, this one is for DC motors and stepper motors. So there are different types of motors. The servo motors that we looked at before are basically a type of motor that you can move to a certain position, and it has this feedback loop that it uses to get to that position. Whereas a DC motor is like a simple little motor. Actually, I've got a little example here, so like something like this. So this would be a little motor that's, you know, you'd find this in like a little toy, like a remote controlled car or something. It's only got 2 wires, so it basically just moves in like either forward or backward, one direction for it. And like you can't choose a position, but you can control the speed for it. And then the other type of motor we'll look at in a second here is the stepper motor. You can actually see this is a picture of it right here in this guide. And so that's a type of motor where it moves in precise increments. And actually, well, I guess you can't see it behind me anymore, but over on this side of me, in my old shot, you could see I had a 3D printer. I have the PrinterBot Simple Metal. And so a 3D printer is basically just a bunch of stepper motors. I was thinking, let's see, JBOD, just a bunch of disks, is basically a way to store data. You throw a bunch of disks into a machine. 3D printers are just a bunch of steppers, JBoss. You know, that should be a new, any kind of CNC machine, the JBoss CNC, just a bunch of steppers, because that's all they are. It's stepper motors that move a tool or a filament extruding head up, down, left, right, you know, in precise increments. So the cool thing is, with this PCA9685 driver, you can control those types of motors pretty easily and do it from MicroPython, and so that's what we're going to look at in this video here. So let's dive in, and like I said, there's a guide that goes with this. I'll put a link in the description when this goes up on YouTube, so you can follow along later and see you know, exactly what you need to do for this. So let's dive in, and we'll jump into the guide. And I'll start with, so the parts for this guide, for this project, read the guide, but you need a MicroPython board. You need the PCA9685 DC motor and stepper driver board. There are 2 versions of this board. There is a feather wing version, which you can see right here, that's attached to a SAMD21. That's a Feather M0 basic proto board. And then the other type is there's an Arduino shield. So you can get the Arduino shield if you have an Arduino Zero, for example, or maybe, I don't know, something with an Arduino form factor that runs MicroPython. So either of those options. There's no breakout for this because it's kind of a specialized board. It's really just the PCA9685 and then these H-bridge drivers that are basically higher current motor drivers. And so by using that PCA9685, which is just a PWM driver, it can send a PWM signal into these H-bridges, which will power a motor, because the PCA9685 can't send enough power. You know, some of these motors can pull like an amp or more of current, and you don't want to try and do that from a little PWM driver. So both of those together kind of form the motor shield or the motor feather wing. So it's not like one single kind of chip or breakout. It's kind of the collection there. Really nice design. That's kind of an old classic, I think, from Adafruit that's been around and been revised over the years. Again, you do have to have an external power supply, and you really do want a good external power supply for motors, because like motors, and I mentioned in the guide, you know, see the motor guide. There's a great motor guide on Adafruit's learning system. I mentioned it in the first page on the overview. But motors, they can pull a lot of power. Like if you stall a motor, it will suck down an amp. Even these tiny little servos, hobby motors, you know, these things might pull like an amp or more of current. That's a lot of current. That will definitely fry your board if you try and power it from that, in most cases, unless you've got some fancy board that's got a really nice power supply available to it. So long story short, check what motors you're using, check what voltage. The two different motors I'm going to look at today, one of them runs at 12 volts, the other one runs at 6 or like 3 to 9 volts or so. So again, don't be an idiot and send 12 volts into a 9 volt only servo like I might have done earlier today. So you might have some fun with that. You also need some motors, obviously, like a DC motor, stepper motor. And again, if you want to deal with servo motors, go back to the previous video I did on the servo wing, which is same driver chip, the PCA9685. It's just, it doesn't have these H bridges to drive the higher current motors like this. And then obviously some soldering tools. You're gonna have to assemble the feather wing and put some headers on here for it. So to wire this up, it's actually really easy. Because this only comes in Featherwing and Arduino Shield form factor, you just plug it into your board and you're good to go. It uses I2C, so if you're not using a board in that form factor, hook up the clock, the data line, the power, and the ground, and you're good to go. But again, I mentioned the external power. You have to make sure that you get correct. Now, hooking up the motors, I'll show you in a second here. So for a DC motor, there are basically 4 terminal blocks on this feather wing here. So there's 1, 2, 3, 4. That's kind of their number. And each of those has 2 screw terminals. So a DC motor usually has like 2 wires connected to it. So like with this motor, you can see the 2 wires over here. And you just connect those into the 2 screw terminals. It can go either way, and basically if you reverse the order, it's just going to reverse the direction that the motor spins. But the library that we use has a forward and backward command, so it just changes the meaning of what forward and backward means for your motor. Now a stepper, this is a stepper motor on the right here. They're a little more special, so they have a bunch of coils inside, and I linked to the stepper motor guide. Like, take a look, and actually I think it shows like a cutaway of what's inside of a stepper and how it works. Real neat little thing. It's like a bunch of electromagnets basically. But so you individually have to control each of those coils, so that's what each of these wires coming out of the stepper looks like. So I actually have a little stepper right here that we'll look at in a second, but you can see there's a lot more wires coming out of this. There's 5 wires. One of these is ground, and then 4 of them go to the different coils inside of there. And so those hook up to an entire block of 2 terminals. So the M1 and the M2 terminal on here, all 4 of those screw terminals are connected to my stepper motor here. And then there's a ground wire that I also have to connect onto this stepper for this. And it differs by each stepper. I mentioned in the guide, there's a guide page that I linked to that says how to use a stepper motor. You can figure out which the coils are, but look at the product pages. Like for this 12 volt geared reduction stepper motor, the guide page actually tells you, the purple wire goes to this coil, and the red wire goes to ground and things like that. So look for that info, look for a data sheet, and that should hopefully help you out a little bit for this. Okay, so let's start with just the DC motor, and I'm actually going to use a different type of DC motor for this because like I mentioned, I may or may not have fried this motor, but this motor, you might notice I actually have capacitors soldered onto it here. Let's see, let me show it up closer here. This camera will probably have a better view. You can see I soldered these capacitors. Oh, it's trying to focus on my face. I got to hide my face here. Let me see, there we go. So you can see I soldered these on, and I put a link in the guide to why I did this. So under the software page for DC motors, I mention right here, this motor guide FAQ point. So these little motors can generate a lot of noise, and I actually ran into this problem. And that noise can affect your development board. So noise is like a signal that can intrude on other signals because this motor has a bunch of magnets that are spinning around. And when you spin around magnets, you're going to create a moving electromagnetic field, and that's going to induce current into like wires. So, these little wires right here actually turn into antennas that can broadcast a bunch of noise out to your circuits. And when you have a nice little development board, like, a feather or something like this, that's got all of your microchips just out in the open, there's no like EMF shielding on them, for example, they're going to suck up that noise, and if that noise goes into like a critical clock line, suddenly your CPU is not running the way that you expected it to run. And so I noticed a lot of weird problems, but like I said, go to this FAQ page entry. If you see weird behavior, like you're trying to run the servo or the motor and your board is like resetting, or it's just not moving or anything, nothing's happening, could be this noise issue. So you can solder little capacitors onto there to decouple or kind of filter out some of that noise that's created by this. Okay, so Software-wise, this is exactly like the last guide. Again, it's the PCA 9685 library. This is a link to it on our GitHub repository. Go to the releases and grab all the .mpy files from here. There's 4 of them. I actually added an extra one, so there's a new one for the stepper motor driver. Download all these files and copy them onto your board. I'm going to skip doing that just because I've done this ahead of time, but I'll just show you. So I'm using the Feather M0 MicroPython right now. That's underneath this Feather right here, the motor wing. But you can see this thing has a USB mass storage mode, and I've got all my MPY files copied over here. So, you know, we're good to go software-wise with this. And now the usage. So it's very similar to the previous libraries. First thing you have to do, initialize the I2C bus. So let's connect to our REPL on this board, and let's do that. So we'll import the machine module, and we'll create the I2C interface. And again, this differs between each board slightly, and I mentioned in the guide, there's a guide on I2C, like how you identify your pins can change. And for the SAMD21 port, you have to initialize I2C or use a context manager. So I've talked about this in previous videos, but I'll show you here too. So I need to specify the clock line and then the data line for this. And then for the SAMD21 port, I'm going to initialize it just using this init function. I could have used a context manager, but that's hard in the REPL. So, you know, I'm just going to call init right here. Okay, so the next thing I need to do to use a DC motor is I want to import the motor module that's from the motor.mpy class that we copied over. So I'm going to import motor. And I just realized I didn't plug in my motor yet, so I'm going to use this little motor. Now, this looks like a hobby servo. This is actually a DC motor, and it comes from this guy. This is this little red robot rover kit. And we might come back to something similar to this in a second, but these are really neat. You know, you can put these wherever a servo might go, where you might use a continuous rotation servo, but instead of using I mean, you can see I have a wheel on here, so this is obviously made to drive something. But you know, instead of using a continuous rotation servo, you can use a DC motor. So a DC motor is a little bit simpler. You don't necessarily have to have like all 3 of those lines and a PWM signal going into it. You know, you can send more power into these. They might be a little bit faster and things. So like trade-offs, it's a little bit different, but it's simple and easy to use. So again, this only has 2 wires. There's a red and a black wire right here. So I'm going to connect these to one of the motor terminals on this shield, or on this feather wing. So I'm going to connect it to, this happens to be, there's M1, M2, M3, and M4 on here. So I connected it to M4. Okay, so I imported the motor module, and now let's see what we need to do. So I need to create an instance of this DC motors class, and I pass it in the I2C bus that I created and initialized earlier. So I'll make a motors object, and I want to create my motor.DC motors class and pass it in the I2C interface. Okay, so at this point, we're ready to go. It's this easy. I'm just going to move this out of the way so that it doesn't go driving off itself here. Oh, and by the way, so I do have external power hooked up right here, and you can see it's kind of coming in from these wires here. This is coming from a bench supply that I have, so just, you know, a little bench power supply, and it's running at 6 volts right now. So that's what I'm going to power this motor with. Again, look at your motor data sheet. I think that this motor can run off of 3 to 9 volts, but look at the data sheet. I don't remember exactly for this one. Okay, I'm going to hold this because I want to make sure that it doesn't go like spinning around on me. Okay, now to move this, you just call the speed function. So there's motors.speed. Now it takes in 2 parameters. The first one is the index of the motor that you want to spin, because there are 4 motors that can hook up here, and the index is 0 based. So even though this is terminal 1, it's labeled M1, this is index 0. So 0, 1, 2, 3. So I want index 3 here. And then the speed is a 12-bit value. So that's a value from 0 to 4095. And it can be positive or negative. So negative 4095 up to positive 4095. And if it's negative, it just goes backwards. If it's positive, it goes forwards. And at the highest value, 4095, that's the maximum speed. And the lowest value, 0, is stopped. So let's just try like 2000, you know, like a moderate value for this. So I'll do that. And then, hey, look at that. We have motion. Now you can stop this. And an easy way to stop this is there's a brake function. So if I call brake, like, you know, brakes on a car, and I pass it the index, I don't have to pass it a speed, then it'll stop. And what that does is that basically just sends in like a reverse, it just turns off the signal that's driving this and will quickly stop the motor from spinning. But that's really all there is to controlling the motor. And I can do, let's do a negative speed, so we'll see it spin the other way. for this. Oh boy, well, we don't see it spin the other way. Let's try that again and see. There we go. That's interesting. Again, this is experimental firmware. Sometimes there are issues. And then I can also set it down to 0. So that stops it also. Another way to kind of break it. Break in the sense of stop it. So that's it for motors. So you can have up to 4 DC motors connected to this board. It's pretty simple and pretty straightforward to use these. But again, be careful if you're using like these little hobby motors. You might run into noise issues, and so be aware you might need to use some decoupling capacitors for that. Okay, I'm going to exit out of the WebREPL and reset my board just because I want to make sure I have plenty of memory left over for the next thing. Okay, so I'm going to disconnect that DC motor. So let's play with a stepper motor. So I'll move this guy over here so you can kind of see it. Now, this is a motor, and let me just show you. So it just has a shaft right there, and I just put a MicroPython sticker on there. Not a nice MicroPython. This is a nice MicroPython sticker, but not as nice as the big MicroPython stickers that we have in the shop now. This one actually came with the Pi board. So if you want a mini MicroPython sticker, buy a Pi board, and there's probably one in there. If you want a big one, then go to the shop, and I'll put a link in the description below. You can get a cool sticker, which I don't have yet, but I probably should. Okay, I'm going to up my bench supply to 12 volts because this is a 12-volt stepper motor, and actually its ground is disconnected right now too because I didn't want it to be getting weird signals for this. So let me change my power supply real fast to 12 volts. So we'll crank that up and turn it on. And then let me hook up the ground of my stepper motor. So there we go. Okay, so the stepper's hooked up, and again, I have this connected to all 4 of these terminals for the M1 and M2 terminal here. Like the pair of those together can power one stepper, and then the M3 and M4 up here, the pair of those together can power another stepper motor. So you can have 2 stepper motors connected to the feather wing like this. Okay, so let's reconnect to the REPL, and let's reinitialize I2C. And again, I'm just going to follow the guide here. So for stepper motors, again, we've got to initialize I2C, and then we'll use this stepper class. So I2C equals machine.I2C, machine.pin, clock line, and then machine.pin the data line, and then initialize for the SAMD21 port. Okay, now at this point I want to import the stepper module, and inside of here is a steppers class, and I want to create an instance of that. So we'll say steppers equals stepper.steppers and pass that in the I2C bus. So I do that, and this library is really similar to the Arduino library. If you use the Arduino Motor Shield library, I basically just copied it. I only implemented the one step function, which moves in one step, but that's the basics. That's all you need to use a stepper. Okay, so the way this works, you have to get an instance of a stepper motor class, and so I'm going to say step 0 because there are 2 steppers. There's stepper 0 and stepper 1. Stepper 0 is the stepper connected to M1 and M2, and stepper 1 is the stepper connected to M3 and M4 over here. And so stepper 0, that's what I have right here. So I want to call stepper.getStepper and pass it the index, so 0 right here. And that gives me back an invalid syntax. Oh, I should have an equal sign there. So let's say, let's assign that variable to something. So okay, so just to show the line, here's what I'm doing. So, oh, that's interesting. I don't like the naming. I should have changed the name of this. So I just called stepper.getStepper. That's trying to call getStepper on the stepper module, which I don't want. I want on the steppers object that I created right here. So this is, hey, this is live coding, so things like this happen. Okay, now I have my stepper motor object. And if I look at this thing, you can see it's an instance of the stepper motor class, and I can look at the functions on it. And so it's got a few things on here that you don't really want to deal with. The thing we care about is this one step function. And so if you go to the guide, I talk about, so one step, this is just like in the Arduino module. You call one step, so step 0.1step. And there's basically a direction, so you can say I want to step forward or backward. That's which direction it's going to spin. And you pass in a constant, and this constant is on the stepper module, so not on the steppers object, but the stepper module itself. And this is a little confusing. Maybe at some point I might want to change this. But so stepper.forward, and remember you can tab complete, that makes it a little easier. So let's move it forward. And then there are different styles of stepping. So there's a single step, a double step, an interleaved step, and a micro step. And I support all of those. I implemented all those just like the Arduino library has. And I'll just talk a little bit about the differences. I don't honestly understand the total difference in these. I'll kind of wing it. Read the stepper guide. I think it goes into more detail there. But let's just do a stepper.single step in this case. So I'm going to do this. Look at the sticker. We might not see much happen though. So let's just see when I hit enter. So not much happened. Now something came back. You can see this 16. This actually returns a value and it gives you the current step position, because the way that this module works, it has to keep track of what step position it's at, so it knows like which coils to energize at the right points. So as you call this, you'll get a return value back. I mean, you could just assign this to something, or actually here, let's go up here and we'll go back and like we'll just assign this to like the current step so that we don't have to see it all the time. So okay, so I can call that, and so you might see as I call this, you know, it's slowly starting to move around. And I'm holding it, so I can actually feel it moving a little bit. Let's throw this into a loop though. So for I in the range of, you know, maybe 200, let's do step equals step 0.1 step, stepper.forward, stepper.single, and then let's just let that thing run. So now you can see it's moving. So as I kind of hold this, there we go. We're starting to kind of slide around here. So it's, well, it was moving. I think the sticker is actually kind of sliding off of it a little bit. So it's, yeah, it's moving in kind of weird ways, but trust me, it moves correctly. It's just this sticker is kind of not on there super well, so it kind of slides off of it. But that's all there is to using a stepper. So it's pretty simple. You call the one step, you get a tiny little step of movement here. So like I said, there's a single step, there's also a double step, an interleaved step, and a micro step. Experiment with them and try them out and see how it works. The micro step, from what I understand, is a very small step, but very smooth. So if you do a lot of micro steps, you can basically get like a smoother movement for something, like if you're maybe trying to precisely control a camera or something like that. Whereas like a single or double step is maybe a larger step, so you can move over like more kind of motion based on those. So experiment with it, try it out and see how it works. Okay, so let's go on to the next thing. I'm going to shut this down and we'll close that out. So I wanted to play with a fun project. So let's apply our DC motor stuff to something like this. So this is the robot chassis that we have in the shop. I'll put a link in the description below. This is the round robot. Let me zoom out the camera. We'll go to a very wide shot of, look at that, a clean desk. That's kind of a rarity for me right here. Now I'm going to turn off my power supply. So yeah, I don't need that anymore. I'm going to unplug my board. I do need to pull my motor driver out because I only have one version, and I probably should get a second one because knowing myself, I will probably damage this one in some way at some point. So okay, I'm going to unhook the stepper motor there. I'm going to unhook the ground right here. I'll keep the power because I'll show you why I want this in a second. Okay, so we're going to pull off the motor wing and we'll move these out of the way, clear off the desk. So this is just the motor wing, so you know, nothing crazy. I just pulled it off here. And now here is our robot. And I guess actually here I'll zoom back in so you can kind of see the robot in a little better detail. So this is the round robot chassis in the shop. This is really cool. I think it's 20 bucks if I remember correctly. It's a kit that comes with the frame. These are motors. These are DC motors right here. The wheels also come with it. It does not come with, this is the feather doubler, and then this is an ESP8266 feather, so this doesn't come with it, and there's a battery in there. It doesn't come with that. But you basically get enough. There's a little a caster right here that it comes with, so it can sit as a robot. And so it's two motors, two DC motors, and then you can hook up, you know, feathers, Raspberry Pi, whatever to this. You know, I'm going to use feathers for this. And it's nice in that just with those two motors, you know, you can move this forward, backward, you can spin it around left and right by moving them in different directions. So I was thinking, let's do a MicroPython robot. Like, you know, this is something I've wanted to do for a while. And the ESP8266 is great for this because it's got the WebREPL, so I don't have to have a wire connected to this thing. I'll actually use the web page itself to send commands to control this robot. So first, let me hook this up. I'm going to put my motor wing back onto this doubler board. And the way that this doubler works, it's just like if you had stacked these boards together. So, you know, I could stack the motor wing on top of this ESP if I had stacking headers on there. But this is kind of nice in that you can have two things sitting side by side and then even stack on top of those if you want. But it's kind of nice. So it's just basically making a connection between these two feathers and the feather wing. Now the power line, so you know, this motor wing needs a power input to it in order to drive the motors. And the way I'm going to power this board is basically I have a little wire connected to the positive input of the power, external power. I'm going to connect that to the BAT, the VBAT output on this feather wing. And so that VBAT is going to be connected to the VBAT on my ESP8266. And that's basically just a direct connection to the battery that's connected to your device here. So I'm going to plug in a little li-poly battery, and actually first I'm going to connect my motors. So over here I just have little bits of wire, and then these are my two motor connectors right here, and so I'm going to just connect my motor here. This is a good way because this is a female socket and this is a screw terminal. How do you connect those? Just take a little strip of wire and you can just plug these right in like this. It's super easy like that. Okay, so I'll plug in that motor, and then this motor I'll plug in the same way right here. Get those right into the right spot. There we go. Okay, cool. So that's plugged in. Power's plugged in. I don't need to plug in ground because the ground is already connected internally for this, but you know, it doesn't hurt. You could do that. And now I'll plug in the power. And so under here, I just have a little li-poly battery. You may or may not be able to see that little silver thing back there. So I'm going to do that. And okay, cool. And again, like you do need to make sure that your motors can be powered off of 3.7 volts, which is kind of roughly the li-poly battery voltage. Luckily, these motors have a range of like 3 to, I think, 9 volts. Check the product page, but they work with a lithium ion or lithium polymer battery, so this will be fine. Okay, cool. So we've got our little robot set up here, and let me zoom back out to, oops, there we go. So we'll zoom out to the full desktop. And we'll kind of move these things out of the way here. Okay, so now my ESP8266, it's booting up, well, it's booted up actually, and it's gonna run the WebREPL. And so I'm using the 1.8.5 version of the ESP8266 MicroPython firmware, the release version, not an in-development version. And the release versions by default enable the WebREPL. I did a whole guide on WebREPL stuff, so go check that out and a whole video on it if you're curious how to use the WebREPL. I'm going to connect my Mac to the ESP8266 right now. I'm just going through, and okay, so it is connected. So I have Wi-Fi on this Mac, and it's connected to my ESP8266. And so now I can go to, this is the WebREPL client. This is just the one that's hosted on the MicroPython website. And if I click connect, then hey, it just connected, and it needs my password, which I set ahead of time. It's Python, so you can go hack my my board here. And okay, so we are connected to my board. This REPL that you're seeing right here is basically the Python prompt on my ESP8266 chip connected to this robot. So that's cool, like wireless robot control. And again, I have my motor wing connected to the two DC motors on this. So let's start moving this robot around. Now I did something ahead of time. I wrote a little class that I just called bot.py, and I put it up on GitHub as a gist. I'll put a link in the description below to this gist. It's really simple though, because I just wanted to make a logo-like API of, you know, call a forward function or a backward function or a right function or a left function to move the robot. And so, you know, maybe I'll walk through this code in a little more detail in a second, but I just want to mention, you know, I put a little helper class on this board already, and you can do that by just sending the file to the board, you know, through the WebREPL here. That's what I did to initialize it. Or you can use AMPI, you know, lots of ways to put code onto the boards here. Now let me see if I can increase the text size a little bit, because it is kind of small on the video here. So okay, yeah, there we go. That's That's probably good enough. That's better than it was. Okay, so let's first import machine, because to make this work, I have to initialize the I2C bus, and you could put this into a main.py file or something, or your own script, maybe a function that you call that does this. So I need to make the I2C bus, so machine.I2C. Now remember, for the ESP8266, you specify the pins, and for the feathers and feather wings, pin 5 is the clock, and then pin 4 is the data line. That's what you want. And on the ESP8266, you use numbers and not strings for your pins, so remember that. You don't need to initialize this anymore. It's initialized at this point. And now I want to import the motor module again, because I need to create an instance of that motors class. That's how my robot class works. So I'm going to create that DC motor class, say DC motors, pass it the I2C bus. And just to test it out, let's try one of these motors. I'm going to hold it so it doesn't spin around, but let's just call motors dot speed, and I believe this is terminal block 3 and 4, and remember, zero-based index, so that's index 2 and 3 that will spin these. So let's try, I think this motor should be index 2, so we'll say index 2, let's say a speed of 2000, and so we hit enter, and hey, look at that, we've got some spinning motors there, and I can call motors dot break on index 2, and that'll stop it. So there we go. Okay, cool. So that works. So that's good. And again, I mean, there's nothing wrong. You could use this motors class to control your robot. It's just you'll need a motor instance for each of your motors, the left and the right one, and you'll need to call the speed function individually. But that's where my robot class comes in. So I'm going to import the bot module, which is just this bot.py file that I mentioned before. And I'll show you how it works, and we'll walk through the code in a second. Now I need to create an instance of the robot, so I'll say robot equals bot.robot, and this needs to take in an instance of this motors object that I created, so I pass that in first, and then I want to pass in, I believe, the left motor ID first, and then the right motor, which is 3 and 2 for mine right now. So this is just the index, you know, motor 3, motor 2, or motor 2, motor 3, rather, right here, the index. Okay, so that's in there. So now I can call like the forward, backward, left, right turn functions to make this thing work. So let's just call forward. Now it takes two parameters. The first is the speed, which is how fast it should move forward. And then the second is the amount of time. So you don't tell it the distance. That might be an interesting thing to try to work out, like based on the diameter of this wheel and based on the speed that it's moving, you could compute how much distance that it should traverse. Like, there are variables that can affect that, like if the gears slip or the wheel slips or something like that, but you know, it's better than nothing. So that could be a cool kind of future enhancement to this, you know, make it distance-based, because I want to say, you know, move 12 inches forward at a speed of like, you know, 6 inches per second or something like that. But for now, you basically have to say the speed and time for this. So speed, let's say 1,000. So again, this is that 12-bit value, that 4095, positive or negative. But you really want to use like a positive value here, because the robot class internally, I'll show you, figures out if it should send positive or negative values to the motors themselves. Okay, so the speed and then the amount of time. This is just number of seconds, and it can be floating point. It could be like, you know, half a second. Let's just say 1 second. So it's going to move forward for 1 second, hopefully. Let's see what happens when I press enter. So I do that, and oh, hey, okay, so forward's the other way for this, the way these are oriented. But hey, that worked. And again, remember, this is over Wi-Fi. This is a web page that's connected through WebSockets to this ESP8266, which has this motor driver connected to it, which has a couple motors, and this is pretty cool. Now, if I want to move the robot back, let's say robot.backward, same speed, same amount of time, let's say, and hey, look at that, he goes back like that. Or she, and you know, nothing says you know, robots could be girls too. Okay, so now let's say robot.right. So this will kind of twist to the right, and let's do a different speed. Let's say 2,000. Ooh, this is a fast turn. And again, amount of time. So, you know, it might be nice in the future to have like a function that takes number of degrees or something. But again, you're gonna have to work out like how fast and how far it moves based on the amount of time. So for now, just give it an amount of time. So we'll say move right, spin right rather, at a speed of 2,000 for 1 second. So let's see what happens. That was pretty cool. That was fast. You know, let's go even faster. Speed of 4,000. That's cool. That's, you know, hey, it's like it's dancing or something. And then, you know, you can go a little bit slower. Now, there's a limit to how slow you can go. Like if I do 500, you might have heard like this buzzing and nothing happened. basically there's a minimum amount of torque that these motors have to generate in order to actually move the wheels and move the robot, because this robot weighs I don't know, this feels like 8-9 ounces, something like that. And so, this thing's not light, and in order to move this thing, it's got to overcome the inertia of it. And so there's a certain amount of power that motor has to generate before it can actually start moving this thing. And so that's why low speed values might not do anything. So I noticed for this robot, I really have to start like around 1,000 or so to get some movement with it. So, okay, so that's the right function, and then the left function, surprise, surprise, it moves left, moves the opposite direction. And so the way this is working, it's just moving one wheel one way and the other wheel the opposite way for this. So, and again, like I can specify, a different amount of time for this, like how about maybe 3 seconds? So it just does like a nice little spin in place. And then how about robot.forward for maybe 2 seconds, and it drives forward like that. So that's kind of cool. Okay, so I'll show real fast how this robot class works. So it's pretty simple code here. Let me zoom in again a little more. So again, I made a robot class because I didn't want to control each motor individually. I wanted to have this high-level forward, backward, left, right functionality. And so I made a class, but that doesn't necessarily mean that I have to implement everything in the class. So I let the caller of this pass in an instance of that motor controller class. So, remember from the WebREPL, that's this motors, DC motors class that I created here. So that way my robot class doesn't have to know how to create this DC motor thing. Maybe there's a different motor driver in the future that I could pass in, and as long as it has that speed function, everything should work. And then it needs to take in the index of the left motor and the right motor. So, you do need to know, like, what's the index of those motors that are hooked up to your driver. And then I create this drive function internally because my forward, backward, right, and left, each of those is really just moving each of the motors in a certain direction and waiting an amount of time and then stopping. So I didn't want to duplicate that code in each of these functions. That's why I made a drive function that forward, backward, right, left call. And then that drive function is just kind of a generic function that says, okay, give me the speed of my left motor as a parameter, right here. Give me the speed of the right motor as a parameter, and give me an amount of time to run those motors. And then it does exactly that. So it's going to take my left motor and run it at the left speed, my right motor and run it at the right speed, and then it just delays time.sleep for a little while, and then it calls the brake function to just quickly stop right there. So then forward is really just taking in the speed and setting both left and right to a positive forward value, and waiting the amount of time that the user told me. Backward, just take the speed and make it negative. So say, hey, go the opposite direction, both motors backwards for this amount of time. And then right is basically the left motor goes backwards and the right motor goes forwards. So, you'll spin to the right in that way, right here. And then the left is the inverse of that. So left motor goes forward, right motor goes backwards, and you delay for an amount of time. So that's all there is to that robot class, just forward, backward, right, left. And it's pretty cool. I mean, even with that, like, you can have some fun here. And again, this is really cool because it's all from this web page that I'm doing this. Hey, the future is now. I'm controlling robots from the web. And this is so cool that with the interactive REPL here, that, I'm just typing a single command. I'm not like flashing new code to a board and loading it onto here and then watching what happens. I'm just typing in code and we're ready to go here. So this is pretty cool and fun. It's definitely something that even I enjoy. And I've built lots of little robots like this in the past. Oh, there we go. He's almost going off the table there. So let's bring him back forward. So say, how about 5 seconds forward? Actually, let's go a different speed. Let's go fast. Let's do 4,000 for half a second. Let's see what that does. Oh, that was cool, kind of cool. Well, we almost flipped ourselves over there, so that's fun. And you can't see. I just had a light go out. Battery. Let me do a on-the-fly battery replacement. Hey, I'm ready to go. There we go. Look. Oh, hey. There we go. Almost went out there. Okay. Anyways, I was about to say my cat. She's in a box over to the left, which maybe we can see if we slowly. Oh, the other light's in the way. Sorry. Let's turn that off. Okay, this fuzzy thing right here is a cat. Let me pull her over there. There we go. So you can see she's noticing the robot. I will move the robot. How about we'll spin it in a circle at a speed of 4,000, and we'll see what the cat thinks of that. So hey, are you ready? You ready to spin this robot? Nope, she's not impressed at all. So hey, cats are cats. They do what they do. So anyways though, so that's all that I really wanted to show on this stream. Again, this was how to use the DC motor and stepper driver Featherwing or Arduino Shield with MicroPython. So you can control DC motors, that's simple motors like I have right here that just move forwards and backwards at a certain speed, or stepper motors like, you know, this one that we saw earlier, where you can kind of precisely control how many steps or little increments of motion this motor makes. And so like a 3D printer or a CNC machine, something where you need to precisely move something, the stepper motors are great for that. So, and then at the end here we did this little demo with the ESP8266, the WebREPL, and a robot here that you can see that I'm just typing in commands and making this robot spin around. So we'll say left, how about 3,000 speed for 10 seconds. So it's going to do a victory dance right now, so we'll move things out of the way. So there we go. That's the robot victory dance. 10 seconds of spinning around. Well, see, now the cat's looking at it. You can't, after I move the camera, of course, she doesn't care. So, okay, if folks have questions, throw them into the chat, and I'll see if I can get to them. It doesn't look like there are too many questions. And again, this is all related to a guide. There'll be a link in the description below. So check out this guide. It has all the details on how to use these modules and create this project. And the robot, I don't mention it in the guide, but I'll put a link to this code right here for this gist of how to create this robot class. But really, if you can control motors, you can control a robot. That's all you need to drive this robot. It's just 2 motors to make it go forwards and backwards for that. So. Okay, so I'll jump back to the main shot. We'll say, uh-oh, and I left the other shots on. Look at that, I'm an amateur at this. Okay, so anyways, so thanks a lot for watching. It's Tony from Adafruit. This was the PCA9685 DC motor and stepper driver with MicroPython video. So it goes along with the guide. Check out youtube.com/Adafruit. You can see this video and all kinds of other fun project videos there. Check out twitch.tv/Adafruit, and you can watch me stream these things live. I like to do a couple streams a week. I used to do streams on Mondays, but I'm moving those to Tuesdays just so there's a little more time to get things ready. So look for Tuesdays and Fridays. I like to do a stream also. So check those out, and you'll see all kinds of fun MicroPython stuff. There's still quite a few more Featherwings to get through, so I'm going to get through all of those with MicroPython. I think at least maybe 2 or 3 more weeks of that. And hopefully along the way we'll do some fun projects like this little robot. You know, maybe we'll start getting into some IoT, Internet of Things projects in the near future. So anyways, like, comment, subscribe, let us know that this is interesting stuff and that you're getting good info from this video, and we'll keep making stuff like this. So, oh, now the cat runs away. There she is back there. So I guess we'll end this with the cat. It's I guess it's time to clean herself or something at this point. So anyways, Tony from Adafruit, thanks for watching. I'll see you guys next week.